Welcome everybody to the October 10th Integration Quest study group. This is my very last day before heading to Dreamforce. I'm flying in the morning. Dreamforce isn't on the weekend, but I'm going to be up there in San Francisco with a bunch of people who have like these plushies and stuff. I'll probably come back. Actually, I already know I'm going to come back with more of these guys. That's the kind of thing that happens at Dreamforce. So anyway, I thought it'd be a good time. I was looking back at our study group history, and we have never yet done a study group on like the basics of DataWeave. We did advanced DataWeave stuff, but we never did a basics one. So I thought I'd put together. Now I started out with some transformation logic from one of our courses. We have what's called professional integration with MuleSoft. So this is like I kind of took it out of one of our paid courses and turned it into a study group, which meant I had to shorten it a lot. So gives you a taste of what we do in classroom. Anyway, so DataWeave, it's a MuleSoft created proprietary language. And that's what this is meant to be, is a short intro to using it to do transformations. There's a couple of ways to come at DataWeave. One of them would be more like as a programming language, which that's a fun way to do it. Today, I wanted us to start out though, with a much more practical introduction to the language, like what I would actually use it for, even if I've never seen it before. So that's the intent of this workshop. So off we go. Introduction to DataWeave. So it's a functional language. It's a program. That means it is a programming language. It's a interpreted programming language that runs on the Java platform. The libraries for DataWeave, some of them are open source, some of them are proprietary. So we're still kind of in a wait and see period for the last 6 years about how hard we can go on using DataWeave in open source solutions. It is not officially open source, but there is an open source way to run DataWeave called the DataWeave CLI, command line interface. So you can run these transformations from the command line if you want. Of course, the primary place you use DataWeave is inside Mule applications for integration. So it's a functional language, kind of like Excel functions, but way better. If you've ever written an Excel function, you might have bad memories of how nasty that language is. So this is like the good version of Excel functions. From a practical standpoint, that's how I would want you to think of DataWeave as a language. So it's a declarative language. Your program creates a data structure. The output of your DataWeave expression is a data structure, and then you annotate, you give a declaration of your program of what the format is going to be. So DataWeave makes a big distinction between data format, which is like the bytes and characters and serialization, right? Turning data into like what goes over the wire. That is not, you don't write code for that in DataWeave. You just tell it, I want XML, I want JSON, and you guys are about to do that. So this is going to be an interactive workshop. It'd be nice if you had 2 monitors. You're going to get to see what I mean by the difference between format and data model in the DataWeave language. So get your Chrome browser or some browser that does tabs on a separate screen so you can watch my screen and do stuff on your screen. That's kind of and I like that teaching style. I think it's very instructive to actually go hands-on when you learn this thing instead of just listening to lectures. So I'm going to give you an XML file that looks like something you would normally have to transform. We have in our new classes, we're using an EMS, emergency response use case. And so what we have is we got this fake XML data that's like the billing export from an EHR system. Like all of these patients came in and here's how much we have to charge them so we can send it to the insurance company, right? So this is going to look kind of like a gnarly XML that would come out of like a 1992 EHR. That's kind of and I'm going to give you it in a few minutes so you can actually use DataWeave to turn it into something else. And that's what we're going to do that in I mean like 1 minute, like right now. So let's do it. Ready? Let's make some XML dance. You ready to make XML dance? I'm the only one on camera. If you're dancing, I can't see you. All right. 2 links to open up in your web browser. And I'm going to put both of these in the chat too, so you can click them. You want to get into the DataWeave playground. This is a live coding environment for DataWeave. It's not my favorite one, but it is the easiest one to use in a 1-hour workshop. So that's what we are going to use. I like to use a DataWeave Visual Studio Code extension, which works a lot like this playground. So let me show you what that looks like. Looks like this. this is the DataWeave. And if you're watching on the video, I really do recommend that you pull up a computer and open up the playground, because whatever you put in the middle is going to evaluate on the right side. That's often called a REPL, read, evaluate, print loop, right? So you can change the code. You see how I'm typing code in here, and whatever I'm typing is rendering on the right side. So all of you guys can do that right now, right? So I recommend you pull up the playground. So there is a REPL that you can install on your own machine that has no usage limits on it, right? So it's like that's what Visual Studio Code is for. But we're going to use the REPL we're going to use the playground for this session. You can close the little Salesforce ad at the top. Here we go. All right, cool. Next, I created a code share. So I'm going to give you that link as well. This is the code share. It looks like this. CodeShare is nothing to do with DataWeave. It's just a site I use for classes. So anything I type in here, you can copy paste, and then you can type in there too and be on screen in the video if you want. So I'm going to put some code in there, and you're going to be able to download it, right? So we're going to get the code share up. Let me give you that link. And I'm not going to be pulling that up on my screen too often because I just needed to share code with you guys. So let's put that in the meeting. Here we go, code share. And in my classes, especially my DataWeave classes, I do a lot of code share stuff because I want us to stay together. And, you know, each little step, sometimes people have a syntax issue or something. You can, if you want, completely do it all by yourself, or you can, whenever you want to take a hint, you can go back to my code and copy paste stuff. So it's a good way to kind of stay with the stay with the me where we're going. How do I get this to go back to presenter mode? Hope I'm doing it right. Okay, good. So good. I hope you're all in the code share and you're all in the DataWeave playground. Now I'm going to give you some XML code. So I told you we're getting started. Here we go. I have it here. I kind of spent the last hour getting this ready for you guys. So in the code share, you're about to see a whole lot of XML code. Boom. So that's the XML code that's the XML data that we're going to use as our input, right? So I want you to take that and go to your playground and click on payload on the left. You see on the left side, this input explorer. This is meant to be like, what's my input that I'm transforming, right? So I'm going to click on that JSON payload. Now it says JSON, so it's not going to work, but we can just overwrite everything that's in there. And then make sure we change the MIME type at the top. That's what this is. It's a MIME type to XML instead of JSON. And of course, we have mess on the right. Don't worry about the right. But you want to just get the XML inside your payload. And when you hit the back arrow, so when you click on payload, it puts you in a little editor. And then there's a little back arrow next to it. And that puts you back in the list of inputs. You can make more inputs. We're just going to have payload. The word payload comes from MuleSoft. It's meant to mean the data that I'm working on. So it's very common to have DataWeave transformations that operate on an input with the name payload, and then that input has some kind of a MIME type, so it might not be XML. So we wanted to say we have an XML payload in this case, and that's a convention from Mule. DataWeave actually doesn't care. Your input can be named anything, and DataWeave is fine with that. But we're using payload because that's very common in a Mule application. So if we take off this REPL stuff, you're going to get null on the right. Cool. Let me stay on track. Where am I at here? Okay, we got the billing sample XML in our playground, and I want you to be able to do something with it very quickly. So we're going to do something with it very quickly. Just write that in the middle under those three dashes, data : payload. And a lot is happening with very little punctuation here. So we're going to get to see quite a bit. I wanted you to see like kind of like a magic wand do a really big spell. The very first thing on the code example. So let's do that and see what it does. Data : payload. And whoa, we got all this output in JSON format. So we started with this big XML file and we finished with this JSON over here on the right. That's the kind of thing DataWeave does. And there's a lot of lessons in this little bit of code in the middle here, right? So I kind of want to do a little tour of the DataWeave syntax, because this is the beginning. This is the beginner lesson, right? And these 3 dashes separate the header from the expression. And all DataWeave expressions have only one header and one expression. So the 3 dashes are certainly required. If you do 4 dashes, it will not work. If you do 2 dashes, it will not work. It has to be 3 dashes. The directive at the top says that this is a DataWeave 2.0 file. I've noticed in some of the online documentation, later versions of DataWeave are, they do work, but I never have to use a different version up there in my day-to-day practical coding. And if I'm wrong and one of you guys does, send me a message, put a comment on the YouTube video. That has never been that important. That's kind of like the XML processing instruction that we have at the top up here. You just kind of have something at the beginning to tell the computer, what does the rest of this text mean, right? So after that, you're going to have header stuff, and we only have one line in our header, and then you have an expression below. Our header here has directives. In this case, it's an output directive, and that tells DataWeave what format the output should be. So if you change that output directive from JSON to XML, magic. That's why I like this language, right? Look what just happened. I mean, now we have an XML output. And if I do data colon payload, you can kind of see what it does. Right now, there's a lot happening here that's because of a very special syntax I'm using. I kind of prepared the example, right? But we've now got XML, and you can kind of collapse it in here so you can see I kind of like the DataWeave preview because you can do that, right? You can kind of collapse the data and look around XML documents. So what we're doing here is we're kind of just changing the data model in RAM. So the middle expression says, take whatever my input data model is. And since we told DataWeave on the left that the input MIME type is XML, it takes all these characters and sucks it into RAM and creates a big data structure in RAM. That's an internal DataWeave format. And that one looks like this. You can actually view that format by changing the output directive from XML to DW. And you can really see this is what's in RAM for DataWeave, except it's rendered to text so that we can look at it. You never want to use this in your real code. This is only for debugging, right? But you can see the type system. You can see all the guts and internals of the DataWeave data model with this DW format. So that's what's really happening. It reads the input, and it knows that it's an XML because the input comes with an extra little MIME type on it. And it says, put that in RAM in this form, in this structure, right? And so it pulls the XML in based on what the data really has in it. And it creates a dynamic data structure in RAM. And then we give it an expression. So it makes a new data structure using that expression. So this is RAM to RAM, data structure to data structure. And now we got to go back to bytes, right? So you use the output directive to tell it what bytes to go make. Right. So we say, go make some JSON. And what that does is it gets all of the marshaling and unmarshaling out of the way. So we can just focus on transformation down here below the 3 hyphens. All our job is turn it from one thing into, we just want to turn the data into something else. Right. So I want you to leave it in JSON. Our whole example is going to be based on JSON, which kind of rhymes. So let me go see where my notes are. I had a little lesson plan here. And I'm talking. So any questions about, that's a lot we've already seen for people new to data. Any questions about this whole language or the formats or the MIME types?
Hi, don't mind me unmuting. No, this is great. This is really neat. This is the tool I would use for a lot of things, just for debugging data.
Yeah.
I mean, wow.
Yeah, and it's because it's the open source command line. If you want to use it for data prep, you don't have to pay anybody. You just download it and use it. So that's even if you're not a MuleSoft customer, there is one way to actually do that. Okay, where were we going? Cool. Okay, now I told you we're gonna make XML dance. That's right. That's what the title of the slide was, right? We're making XML dance. So let's do that now. So let's look at our input data. Our input data has an element called billing export data, right? And you can see it in the output. So we're going to use what's called a selector. So after payload, put a dot and type billing export data, and it's going to select the billing export data field from here, and everything inside that field. Maybe it's easier to show you guys in a text file. Oh, this is full screen. No, it's not full screen. Why can't I bring it over? Well, I'll just make this bigger then, right? So everything inside billing export data is what gets rendered on the right. So it takes the contents, which has a metadata and a records, right? And a count, and it puts those contents into the output. So now what we've done is we've said create a field called data and then put the contents of billing export data inside it. So now instead of saying billing export data, it says data, right? And if I made this XML again, I've basically just renamed the root element, right? I've changed it from billing export data to just plain data, right? So, and then we can keep going, right? We can do dot metadata, and now it'll just be the contents of the metadata node. Or we can do dot records, right? And it'll be the contents of the records node. That's what I meant making XML dance, right? We can get anywhere we want in our data and do things with it. I want to do a little more with selectors before we go on here. Let's do after the dot records, do a dot and then use the @ sign count. And we'll look at our input. Our input has records count equals 3. So this is kind of like the DataWeave version of XPath, right? I want to go in to this very one spot in the document and get the attribute of the count attribute of the named count from the records element. So we did that. We went in a document, we got what we needed, and it output the number 3. But you notice the number 3 is got quotes around it, right? Because JSON knows about data types, and so I'm gonna leave that as a teaser. We can do more with that coming up. All right, so backspace over count. Cool. And all right, let's try something else now. What we're gonna do is let's take this, instead of putting data, let's call it. I want to put some syntax around it. I want to show you the magic that's been happening, because you see how you got curly braces. So it's an object on the right. It's like a map. Or a dictionary. So if I put curly braces around the expression we've been typing, I get the same output as if the curly braces were not there. This is a little bit of what we call syntax sugar. In DataWeave, if you just put a single word with a colon, it behaves like an object with a single field with that name. It's exactly the same thing as having the curly braces here. But you do need the curly braces if you're going to put more than one thing, right? So let's leave that there. And then we can do, it's not white space sensitive. Sorry, Python folks. So I can put enters there and nothing changes about my output. Let's go ahead and make it do some more interesting things. So what if we do, try to follow my notes here. I don't want to get too far off track. I'm having fun. So, all right, we're going to use a function called size of around records. Now that did something different than the count. Let me put this in the code share so that people can keep up. I don't want to get too far ahead. Where is the code share? Oh, here we go. There we go. So that's where we are. If you wanted to catch up, I put it in the code share. If you joined late, that's fine. The code share, if somebody, actually, let me look in here. Did anybody join late? I want to make sure they get access to the code share. I don't think so. Okay, code share is in the chat. So you now have my DataWeave expression. And what it did was it counted them. See, inside records XML, we have 1, 2, 3 record elements inside the XML records node, right? So the records element contains 3 elements, record, 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 and we use the size of function to count them. So you have functions in DataWeave. That's one of the built-in functions, and there's a whole reference that you can happily access at the bottom of your playground. So you could go find the size of function in here, and there it is. And it's got pretty good like documentation about how it works. So if you want to go shopping for functions, that's a good place to go. So we're going to call this one the total records field of our output. Right, and then we can add another field. Data payload dot billing export data dot records. There we go. Now you see I repeated something. Payload dot billing export data dot records. I repeated 2 times, and when you start seeing that in your code, you have a you want to try to handle that, right? So what I'm going to do is I'm going to go make a variable for that. Okay. So we'll do that. We'll do var rex equal payload dot billing export data dot records. So in the header section, you can declare variables, and that's very handy when your DataWeave code can get super unruly under just in your hands as you're building your transformation out. So you want to watch for these duplication moments and go ahead and replace the same expression with your variable name. And there we go. So now we have one called Rex. I'm going to put that in the code share too. There you go. So DataWeave has local variables. Now I'm getting way ahead here. So we're going to go to the variables part. I got to jump through this whole fancy presentation I made. I wanted to talk about variables. Variables, when you declare them, are read-only. DataWeave is a functional language, which means anytime a variable is declared, it is declared with a final value in it. And they're late evaluated too, which makes the language much more performant. So if I create a variable named Rex, I can't later assign anything to it. It's at the moment that it's been defined. In some languages, they call that let or const. All variables in DataWeave are like let. There's no such thing as the JavaScript var. Everything's just a let. So I think React programmers are kind of used to that too. You have to follow that style in React language. So Rex can't ever change. Once it's got the value in it, for the whole expression is going to have that value in it. Now, inside this data field, I have a bunch of fields that say record, and this is not exactly like you're used to in JSON, right? I got a field called record here, and if you see it, I have another copy of that field. So record colon object, record colon object. That's not valid JSON, but DataWeave will do it if you tell it to. So what we're going to do is use a multi-value selector. DataWeave has this fancy way to take this idea of repeated fields, like in XML, and do dot star record. And now we finally have an array. Right. So now I've got an array of records in my data. And what I really just want out of these is I'm going to get the complaints, maybe. Or I don't have a name on some of these. Why are they all null names? Oh, I collapsed it. Patient info name. Oh, good. Name is null. Oh, because they're all. So let's get all their names, right? We're going to do that. You see how my patients have these names in here, but they're in these weird XML elements. So let's get names. So we're going to take every single record, and we're going to put a .info. Right now, I've got an array of info elements, right? And then .name, and now it thinks it's null, but it's not really null because I can do .at last. And I got an array of last names. All right, so we dug through this whole XML, we counted the records, and then we got an array of the last names. I'm going to call this last names. I just wanted us to have kind of an experience of making the XML dance and getting whatever we wanted out of it This was the same experience I had when I first did XPath, but DataWeave is like way better than XPath. So that's why I teach a little workshop in it. Where are we going? I lost your class. There we go. Good. No questions. Make an XML dance. All right. Well, let's do some more explicit typing then. Now we're gonna go do it ourselves. Oh wait. No, I had a couple more fun things to do. Before I erase everything, let's add one more fun thing in there. I'm gonna add it up. All right. Let's get the sum of all of these charges. You see how every one of these records has a charge, right? So let's do grand total and just put a 0 for now. So now you have 3 records, what their last names are, and we're going to try to add up all these charges. So we do an aggregate function, okay? So usually what I'll do is I'll just do the same thing I did on line 8, and I'll just go get all the charges to start with, and then I'll sum them after I see them in the output. I like the interactive transformation pattern, right? So we're going to go rex again, dot star record. Now this time, let's make sure we know where it's coming from. So the record has a charges in it, right? So here's my record. The record has a patient info, it has an encounter, and then it has a charges, right? So we can do a dot charges. And now what do we have? Charge. And in each charge, there's going to be an amount attribute, right? So I can do dot at amount. Do I have to do dot star? Oh, wait a minute. I can't do dot at amount. The charges has a charge. So dot star charge. There we go. And then dot at amount. There, now we got all the charges. Right? And there's strings. So we're going to have some trouble adding those things up, right? Because how am I going to add up strings? We can try, right? If I do sum, let's see if it'll do it. Sum, okay. I didn't want it to do that. I wanted it to fail so we could do a type conversion because I wanted an excuse to talk about types. So DataWeave has automatic type coercion, and it just did it. So we didn't get to see the error I wanted. But if I would probably make a real function that knew how to convert these into numbers first. So put a sum around that, and we can add up all the charges for the billing data set. So if we were going to make like an invoice or something, right? And we could make tabular data, stuff like that. So, all right, let's get into the real lesson about the variables and the types and stuff like that. So we're going to take this and save it. I'm going to put this in the, oh, you got it? Oh, speaking of the lack of the comma, somebody put that in the chat. I think that was great. At the end of each line, there's a comma. DataWeave is forgiving about dangling commas. So your last item in an object can also have a comma. So it makes me sometimes be a little aggressive about putting commas in there. SQL does that too. I like that, but no, it doesn't. I think you have to put them at the beginning in SQL, don't you? Something like that. Okay, I'm not going to lose this code. I'm going to save this and put this in your code share, and I won't erase it later. So this is the final version of, this is the, here, I'll do like this, XML dance. There you go. And then I'm going to put what we do next at the top. So we're going to take all of this and erase it and just put the number 7 here. And I can get rid of my payload here too. We're going to get to know the DataWeave type system. So 7 is a value, is a scalar value, and DataWeave has an internal type system. It's built with Scala, but it is not using Scala types. DataWeave has its own type system. So if I do type of 7, I will get number. So in DataWeave, there's a type called number. Right? So 7 is a number. And I can also do var x equals 7, and the type of x will still be number. Right? So you notice I didn't have to tell line 4 that x was a number. I just gave it 7, and it figured out that it was a number for you, right? It They call that implicit typing, right? So in DataWeave, we have a choice about typing, right? We can have, what do you see on my slide? We can have implicit or explicit types. Now, I spent a lot of my formative years writing Java code, and I've learned Ruby. So I have a lot of experience with duck typing and implicit types and with very explicit Java types. And I know a lot of people have different styles when it comes to typing. I do like the option, especially when I'm building reusable libraries, to use explicit types. It helps a lot with the editing experience for somebody else. So if you want to use my library, then if I put explicit types all over it, it really helps your code. It helps you write your code better in the first place when you're thinking. The types are a thinking tool for somebody who's trying to use a library. So if I wanted to use X, I can use a colon and I can define the type after X. I don't have to, but I can, right? So it's optional explicit typing, right? X can be a number. So let's do another one. Let's do another one. Var O is equal to 2 curly braces, right? So go ahead and I want you to predict before you do it. Find out, like, get DataWeave to tell you what the type of O is, but predict first. What do I think it's going to output? I gave a hint, I guess. I didn't mean to give too much of a hint. Yeah, and then put it in and see if you're right. All right, I'm going to do it. O is an object. So DataWeave has a type called object, right? And I want to output O, and we're going to explore the object type a little bit because we've been working a lot with these curly braces, right? So inside your curly braces on line 5, we can put something inside there, right? We can put X, which is 7, and Y, which is 8, right? And what I'm doing is I'm defining fields of an object. And I can do X again. X is 9, right? The object is an ordered, I don't know if it's an ordered list of key value pairs. And that's probably a very technical way of saying what it actually is in DataWeave. So if I put XY, XY like this, this is strictly equal to another object only if it has those same key value pairs in the same order. And that helps a lot for XML work, for example. So it's because DataWeave was designed explicitly for transformation. You're going to find that DataWeave is extremely picky about the sequence of things. It is almost everything's ordered. Everything is ordered in DataWeave. There are no unordered types. There's no sets like that. Everything is ordered. And that's because you're going to write it to bytes in the end and send it over the network or stick it on disk or something like that. It's going to get marshaled. And at that point, it's definitely in order, right? So DataWeave doesn't have unordered types at all. So this is an example of that, right? And you can do stuff with that. You can actually manipulate and generate a new object like that. So that's an object. And then there's another type we can do. Let's do like this. X is X. O is O. Right. And we're building, this is kind of a design pattern when we're designing DataWeave, especially in a REPL. We call this, and this is just affectionate naming, I guess, a monitor object. And it just kind of lets me think through my transformation step by step, right? So if I wanted to do bigger, I could do like O plus plus XX. Like I can start to assemble things right out of the previous steps. You know what I mean? So I'll use a monitor object as I build a larger and larger expression, and then I'll end up packaging it all up into vars and functions at the end. But there's kind of an iterative thinking when you're writing DataWeave, where you want to think through just one step ahead, and then one more step ahead, and then package that up with a name and make a variable or make a function. And it's very flexible. The language lends itself very well to that. So monitor objects are kind of a nice interim thing, and then you always delete them when you're done, and you're back to just having O, right? So let's do an array, right? Var a array is equal to empty array, right? And O is an object, right? O is O, A is A. There you go. Let me put all this in the code share again, keep us all together. Boom, there we go. So if you're above the XML dance line, if you're in the code share, that's where we are. Right. And we can have some fun with this. So in the array, let's put A, B, C. Right. And we're going to use some built-in operators here and play around. Right. So if you do A plus 7, something interesting happens. 7 is not a string, right? So this is important. Like because it's implicit typing, it is not requiring the elements of the array to all have the same type, even though the input was originally like that, right? Because I told it was just an array, right? So A could not have an explicit type at all. It can have a type called array also, but it doesn't indicate what the elements of the array have to be, right? But if I do this, if I say that it's an array of string, then suddenly it has to have strings in it. Now, line 16 didn't give me an error, right? And the reason is this is not necessarily an array of string. This is an array of string plus a 7, right? But if I try to put a 7 in up here, watch what happens. Boom. Bad news. So it does care about the type system, right? It's not going to let me put an integer in a string array if I explicitly tell it that it's an array of string, right? Now, I could not tell it so. I could say array of any, and that would work just fine. I could not even give it a type parameter and just say array, and that would be just fine. But if I'm going to insist on strings, then it's going to follow my directions and say, no, you can't put a 7 in there, right? And this is key because right now I'm hard coding my data, but what if it came from an input, right? The input is received at runtime, right? So maybe I declare an array of string and then my input has numbers in it, or the other way around. I declare an array of number and my input has strings in it, right? So the type system works with you as best as it can while you're writing the code, and then it's going to throw errors at runtime if your input doesn't conform to your explicit types. And there's a whole error handling piece that I'm not going to fit in this short study group, right? But know that it is there, right? So we're going to take 7 out of here, and we're going to ask type of A. We're gonna try to predict what is DataWeave going to tell us the type of A plus 7, right? Let's see here. So I'm going to put, what if I type of A plus 7 and try to predict, if you backspace over the comment stuff, what is it the type of that going to be? And then run it. All right, here we go. Let's take a look. It just says array. It's just an array, right? It doesn't know. It doesn't have a type parameter. Now this is something. Type parameters were added later. Let's do another experiment. Type of A now without the plus 7, right? Do type of just A, and see predict what you think you're going to see. And then run it and see what it is. Boop. Even though we explicitly told it on line 11, array of string, DataWeave doesn't know that when it runs. So type parameters are only used by the type checker, not by the not by the reflection piece. So this type of function is doing reflection, right? It's looking at the language while the expression is running, and that can't see these little type parameters. So we use this only for our own code decorations. Now, the DataWeave documentation uses it a lot. Okay, so there's a documentation website here. So if I go into the DataWeave reference and I pick let's pick like the absolute value function. All of these are strongly typed, right? If I put days between, gives me a number. Everything is strongly typed in the core libraries, right? Which makes them very, very reusable, right? And there's a whole bunch of type arguments in here. Some of them we can use, some of them we cannot use. So that type system is available to us. It's not required for use by us, but all the core libraries use it extensively. Let's see where else I was going to go here. Wow, we did a lot about types. Cool. All right, we already did arrays and objects. So let's do some conditional logic. That's right. I had a fun one for that. Let's have fun with this one. Okay. First of all, let's take, I'm going to do one more type for you. Let me take what I have here, drop this back in the code share again. Picking up where we are, right? And I'm going to comment out my big one. So line 15 and 16, if you hold control or command and press slash, the playground has some nice commenting tools. So I don't think I can I do it here too? I don't know. I don't know if I can right click do it, but I can certainly command slash or control slash. I just did that because I wanted to make the output on the right a little shorter with my monitor object. Let's do another type. Var R is equal to 1 to 30. The word 2. 1 TO 30. And then try to predict what R is going to print out when you add it to your monitor object. Boom. Whoa. Which ends up being super useful, by the way, being able to do that, especially because you can also have it be 1 to X, right? Or you could do X to 30. I hope you're starting to see some ideas, right? You can make things happen with ranges. These are called ranges. R is of type range. And DataWeave is very strict about ranges. It only allows you to make ranges out of numbers. You can't do letter ranges, so you have to do fancy stuff. And I have put that in my interview questions before. How do you make the alphabet, right? Something like that, because you can't just do A to Z. That's not a thing. And I'm not even going to give you the answer because maybe you guys will interview with me someday. But you can also go backwards. Let's do that. 20 to X. Right. Now try to predict what will happen if you use the same number twice. What if you did the X to X? You think it's going to be empty? You think it's going to be 7, 7? You think it's going to be just 1, 7? Let's try it. It's just a single number. So it's inclusive. Well, which end do you think is inclusive? Let's do that. X to X plus 1. Both ends are inclusive. So when you make a range, you're always going to have a minimum of one element in the range, no matter which direction you go, right? So if I do X to X minus 1, I get 7, 6. Right? You're always going to get 2 fence posts in your fence. Or I guess you might get 1 fence post in a very small fence. Right? It's not going to keep many cows in. But this is pretty handy for doing transformations, right? Because if I get something like over here in my billing thing, I've got 3 records, and I want to go, from the first record ID to the last record ID, I could just make a little range and go up, and make a bunch of XML elements using that. So a range can be coerced to an array. R as array works just fine, right? And you're back to arrays and use it in array functions. Very good. Okay, so now let's have some fun with it. Let's try a conditional. So I'm going to take this range and say if size of R greater than 5, then we're going to do something. There's a little, this is real syntax in DataWeave. When you're in the middle of an expression, then you can put, if you put exactly 3 question marks, the syntax highlighter won't get confused. And in a lot of languages, I get annoyed that the language servers they don't like incomplete expressions, right? So the 3 question marks helps it make an incomplete expression. And then I can do else something, right? And you notice there's no curly braces around any of this. It's just functional. So if condition, and you have to put the parens on the condition. I just put any expression I want, and then when I'm done with the expression, else another expression, right? If is not a function in DataWeave. There's very few what they call operators, and an operator is something that the language hard codes into the syntax checker. So it's not following the rest of the syntax rules. This is not something you can't make your own if that does this. But it's used all the time. So let's fill in our question marks here. Let's say if it's greater than 5, then let's just put list, the long list, right? Else I can output the list itself, right? So I have if condition, and then I have whatever I want to output. And I like to format it like this. The white space again is up to you, but I'm going to do that. I don't have to do that usually for an expression this short, but sometimes my conditionals are a little longer. So then if I do, x to 30 again, I'm going to get a long list in my and then if I have a short list, x to 3, I get the actual list itself. So this is how you make conditional logic happen in your DataWeave expression. Did you get that? Did anybody get long list? Let's do x to 30 and you see long list. Put x to 3 and you get the actual values. Guess I'll put that in the code share again. All right, I'm watching my time. I've got a big unveil at the end for you guys, so I'm gonna try to make some time for that. All right, I have a real transformation, so you can walk away with a much more like real life transformation with all the bells and whistles, and then kind of be able to dig through it on your own after class. So I'm gonna put that in the code share. So let me put fundamental of types. There we go. So that's what I do with code shares. Let me give you a real DataWeave that I made just for this. Boom. All right, it's above the fundamentals of types. So line 91 all the way back to like line 4 to 91. You can copy the whole thing into your expression here, and you're going to get an actual like a transformation that might be something you really needed to do. Maybe we were going to take this billing document that's in XML and we need to really put it into an API somewhere, and this is what the API is expecting. And there's a lot going on here in this DataWeave expression. So what I thought I could do, just especially because it's recorded and you can kind of go back through and see some of the features of the language, is just give a tour of what's going on here. In most real life XML transformations, you have XML's got this thing called namespaces, and we have that in our input. What that means, and you see it in Mule source code, is some parts of the XML are defined by a different schema than each other. So in this case, we have a patient schema, and we have a billing schema, and we have a common schema, and they're all they come from what XML calls namespaces, and that's where you get this little prefix with a colon, right? And you may have noticed this whole time we've been working with this billing export data thing, but not putting the billing word first, right? Just putting and DataWeave will let you get away with that. But if I want to specifically point to a certain namespace, I need a way to do that. So there's a directive in here for declaring namespaces. And then for my DataWeave program, billing means this, and patient means this, and common means that. Another thing I put in this example is some helper functions. So DataWeave not only has variables, you can define your own functions. These use actual types, right? It's got a little conditional in this one. This one is this one's more like what I would do. Like a helper function is to make my code not completely crazy and ugly, and for a little teaser for what I would call the real developers in here. DataWeave has a real unit testing library And you can use DataWeave testing to test these little functions with actual automated unit tests, like a software engineer, right? What else do we have in here? We've got, well, I wanted you to see an example of the map function. Map is something you use all the time to iterate. I want to apply this. This is called a lambda. You see it's got this record index and a little arrow in there. So you've got a lambda in here. And the map function takes a lambda, and whatever this lambda evaluates to is applied to every item in the input. DataWeave has this infix notation. So any function that takes two parameters, you can provide the first parameter and then put the function name and then provide the second parameter. And that's very handy with lambdas. So this is pretty close to the same thing as if you did map parentheses and then the input and the lambda, but nobody does that. Everybody does collection first, then map, then the lambda. So this whole middle part here is being applied to every record, right? And you can kind of see that out here. Every single one of our records is an item in an array, and they all look the same because they all came out of the same lambda. What else do we have in here that was kind of little nuggets to notice? Some more conditionals. I don't think I did a good. I love date formatting. I don't think I went ahead and put a date format in here though. The default operators in here. That's another one you use all the time. But this is not a lot of exciting algorithmic fun. This is a lot of DataWeave transformations are like any other transformation. You got work to do. I got to go field by field. I got to put the right field name. I got to make sure the output is the right format. And so DataWeave's a great language for just doing the business of transformation. I got to make this output thing that looks exactly like this. So it looks a lot like the output, doesn't it? I kind of got a charges. It looks sort of like this, right? And I think that was part of the inspiration for the language is to make it sort of like a templating language, even though it really isn't, even though it's an actual first-class functional language. So I hope this example is something you can walk away with. I don't know why I didn't check this. Yeah, I'm getting some kind of a false warning in my editor. So if you wanted to play with it more after class, I have time for questions, and I'm going to leave time for you guys to ask. There is a Visual Studio Code extension for writing DataWeave code. Looks like this, and you get it by just installing the Anypoint extension pack, which is a weird name. Like if you search for DataWeave, you can find it. Anypoint code builder, but you don't really just want to install that by itself. You want to do the Anypoint extension pack probably, even if you're not going to do a bunch of Anypoint stuff. It has DataWeave in it. That's what I do, the whole extension pack. And then you can run this stuff on your own machine. You don't need the playground, even though we all love the playground, right? Where did it go? Okay, cool. Great. So I've got some challenges for you. I'd love for you guys to send me your responses. I'm going to let you guys do one right now. See if anybody wants to try to solve it. Right? All right. Oh, I didn't tell you. I didn't make slides for them. I have to just tell you. Yeah, let me put my challenges up. I want you to get the number of records. Here's the records that are ready for billing. I want you to count how many are ready for billing with a DataWeave expression and put it in the chat. Try it in here.
Hi, Ryan. Can we have the XML again? I don't see it.
Oh, well, it isn't there. I erased it. I'm going to go all the way to the bottom after the XML dance and do it. How do I do that? I can't even get down there. Oh, it was a Pluralsight ad. Okay. Source data. There you go. So it starts at line 138 in the code share. So I want to know how many have status equals ready. Now, I didn't give you all the tools in this one. This is a challenge because you got to look up stuff. It's going to be much shorter than this long thing. Why don't I do like this? And then how about another challenge? I'm going to give you the other one since we're on the video. And I'm getting kind of tight on my time. Oh, yeah. How much total, what is the total charge for CPT 99285? Those are your two challenges. And then I'm putting the other one in the chat too. All right. And I don't know if we're going to finish those because I'm watching. I have 1 minute. So we're going to do the kind of the wrap up thing. So I'd love for you guys to hit me. I think LinkedIn is probably where you guys can send me other DataWeave stuff to do in the study group is my idea. And then questions about DataWeave, things we could do in future study groups. That would be cool. And then I wanted to at least mention that this is the kind of thing we do at Integration Quest. We have classes on our website. I'm doing one in November on making AI agents, and you can use DataWeave in it to talk to the LLMs, right? So look at our website for those classes. All right, I'm going to stop the recording. Thanks for watching, and comment if you're watching the video with your answers to the challenges. I want to see your solutions.